Okay. Okay. So maybe we can start now. Okay, sige. So bibigyan consideration ngayon na yung mga hindi yung malilate or ano. But next time siguro kung meron tayong mga cases na ganyan, siguro kung magagawa natin ng paraan na mapunta sa ibang lugar, kung makakalabas, kung able, kung sabihin yung ano, may internet, ganyan. Okay. So ito na, may naka-join na 5. Okay. Meron pang hindi naka-login. Si Pancho. So mamaya pakilagin na lang Marian ay paki-join na lang dito sa ano natin sa Google Classroom natin. Okay. So probably magche-check ako at 3 PM. So nabanggit naman ni John na na si Kyran ay makapasok ng 3. So as consideration, sa 3 o'clock ako magche-check ng attendance natin. But supposed to be ang checking ng attendance ko umpisa, gitna, tsaka huli. So ang na-experience ko kasi kaya gagawin kong ganun, may mga estudyante na pag na-check na yung attendance, nalalag out na, sinasabi, ay sir, nadi-DC po ako, sir, wala kuryente. Kung hindi ko kilala yung mga estudyanteng yun, maniniwala ako, pero kilala ko kasi. So, kumbaga, I don't get the point bakit ayaw nilang umattend ng online class. First of all, bayad dito sa tuition fee nila, ba't ayaw nilang pasukan, or ayaw lang nilang matuto. So, yun lang nakikita kong reason. No? So, hindi ako naniniwala minsan sa nadidisi ako, sir. O kaya minsan tatanong ko yung mga kaibigan ko na nakatira doon sa barangay nila, hindi naman okay na ma-internet. No? So, ayoko sanang ganun na mangyari sa atin. Kasi ECE kayo. No? So, ECE kayo. Take note, ang ECE, meron po tayong board exam. Meron kayong board exam yan. Kahit sabihin niyo sa akin na, sir, hindi naman ako mag-board exam. Ay naku, narinig ko na yan. Ilang taon na ako nagtuturo ng ECE. So ang first batch natin is 2010. Dami ko ng samot-saring kwentong na naririnig, mga palusot ng mga estudyante. And ayoko magpapalusot tayo ECE po tayo. Kung magpapalusot lang tayo hanggang dulo, better think of shifting to another program. Kasi ayoko nang maging mediocre yung natin, yung klase natin. Okay? Kung hindi nyo talaga ito interest, usap tayo, madali akong kausap, ipaprocess ko ang inyong shifting, ganun kadali yun. So, etong ating course, electronic devices, ang mali na type ko, electronic devices to, electronic devices and circuits. This is the foundational course sa lahat ng electronics natin. Sa curriculum kasi ng ECE, we have, I think, parang 3 electronics courses. Sa old curriculum, merong 4. So, ang parang kinompress yung lumang curriculum dito sa bagong curriculum. So, ginawa na lang 3. Meron pa before industrial electronics, yung electronics 4, no? Ngayon 3 na lang. And then we have electives, ECE electives, power electronics, saka solid state pulse devices. No. Papangunahan ko na kayo, this is not a walk in the park. No, hindi siya ganun kadali. Hindi siya madali talaga. No. Kaya I want your cooperation, I want your focus on this course. No. So you are enrolled under the Bachelor of Science in Engineering, Electronics Engineering program, taking up this course, electronic devices and circuits. And meron din pa kayo yung circuits 1. I think kay Sir Calderon siya. Pagdating natin ng second semester nito, yung electronic circuits analysis and design. So medyo mas advanced na to. So meron ng AC analysis ng electronic circuits. That's why I'm asking you na maging focus tayo. Huwag tayong gagawa ng mga palusot. No? Ayoko ng ganon. Aral lang tayo. And gusto kong umunlad kayo pag nag-graduate kayo. Hindi yung nag-graduate nga kayo ng EC tapos ganito lang ginawa namin kay Sir Gani. No, online na nga tayo eh. Online na tayo kaya mas lalo pa tayo mag-exert ng effort para paunlarin yung sarili natin at nandito ako para tumulong sa inyo. Huwag kayong matatakot sa akin, huwag kayong mahihiya sa akin. Ganito lang talaga ako magsalita. Very frank. No? Kasi gusto ko kung ano yung makabubuti sa inyo. Yun ang gagawin natin. Ha? Okay, so I'll be handling electronic devices and circuits kasi nga nabanggit ko sa inyo sa GC, so pre-confidential na lang. No? Si Ma'am Maika, yun ang nangyari. Okay, so we have a total of 6 na pumasok ngayon sa electronics 1. Again, mamaya mag-check ako ng attendance natin. Okay, so electronics, expectations natin for this course, hindi tayo mag-repair ng TV, hindi tayo mag-repair ng radyo. No? Yun ay pinag-aaralan sa electronic technician na test na yun, no? Yung nag-repair ng mga bagay. What we will do in engineering kasi, we design systems, we analyze how those systems work, how can we apply it to different fields such as manufacturing, sa communications, no? Especially sa communications kasi ang electronics talagang ginagamit natin yan sa communications, no? Paano gumagana yung mga electronic devices? Ibig sabihin yung mga from the basic diode papunta sa transistors, yung mga BJTs, mga MOSFETs, operational amplifiers, and all of those stuff. Yun ang pinag-aaralan sa electronics sa engineering. Hindi tayo magre-repair. Okay? So, first is i-define muna natin ano ba yung electronics. Ita-type ko dito itong gagamitin ko yung whiteboard natin. Yung mga PowerPoint presentation na sinend ko sa inyo, yun yung mga succeeding na mga i-discuss natin. Ito mga basics pa lang tayo ngayon. Pero pagdating natin doon sa actual na electronic devices, dito na papasok yung mga different computations, KVL, Kirchhoff's voltage law, and also some of KCL, Kirchhoff's current law, voltage divider, so on and so forth. Kaya aralin nyo mabuti yung sa circuits nyo kasi yung pinag-aaralan nyo sa circuits ay gagamitin natin dito sa electronics. So DC analysis. Electronics 1 focuses on DC analysis. So mamaya ipapaliwanag ko sa inyo, ano man difference ng AC tsaka DC? Ano ba yung voltahe? Ano yung kuryente? Ano yung resistance? So probably na-discuss na ito sa inyo ni Sir Calderon, pero I'll discuss it probably in relation to electronics para mas maintindihan natin. So kung meron kayong questions, by the way, mas maganda kung sa chat, no, mamaya. Doon kayo magta-type para hindi ma-disrupt yung ating discussion. Kasi minsan, di ba, nagkakaroon ng delay, may lag dun sa pagsasalita. So, mamaya, hindi pa tapos magsalita, sasagot na. So, nagkakaroon ng disturbance. Kaya sa chat na lang kung meron tayong mga tanong. Ha? I can also accommodate your questions sa GC natin after we conduct the class. Okay? So, how do we define electronics? Alamin muna natin definition. Electronics is a branch, so itatype ko dito, of science and engineering dealing with the, unahin natin to, capitalize natin, release, control, collection, and energy conversion of subatomic particles acting in materials with known electromagnetic properties. Yan ang definition ng electronics. So isa-isahin natin, no, yung mga terminologies natin yan. Release ako ng pato. Transfer. Branch of science and engineering. So basically, when we say science, there's a systematized systematized way of doing things. So yun ang gagawin natin sa electronics. Meron tayong sistema na gagawin, step-by-step procedure to analyze the different properties of semiconductor devices. And also in engineering, pag sinabing engineering, nandun na agad yung word na design. So we're going to design systems, we're going to design combinations of systems for different applications, different circuits dito sa electronics. No? But mainly yung pinaka-focus talaga natin dito ay our DC circuits. May explain natin yan. Dealing with the release. So unahin natin yung word na release. Bakit? Di ba we have subatomic particles? So we have the smallest part is the yung atom, and then meron tayong proton, neutron, and electrons. Wherein electrons are negatively charged, neutrons are neutrally charged, wala siyang charge, and protons are positively charged. So pag sinabi natin kasing electronics, this refers to the movement of electrons. Kaya nga electronics eh. Yan, no? Electron. Okay? So kapag na-knock off ang electron sa kanyang parent atom, the atom will become an ion. So basic science, no? Sa high school natin. No? And these electrons are called free carriers. Yung free carriers na to, they just roam around within a material. So halimbawa yung copper. Now copper tends to have more electrons compared with other materials. Kagaya ng mga paper, rubber, those are all insulators. No? But conductors have more electrons. That's why kumikilos ito sa loob ng kanyang structure. So there's a release of free carriers or electrons na tinatawag. Pwede natin i-release itong mga electrons na to onto a succeeding device. No? Transfer. So paano natin ita-transfer yung energy na yon or yung electrons na yon from one stage to another? For example, sa isang cascaded na amplifier, no? First stage, second stage, third stage, so on and so forth. So tina-transfer natin from one point to another itong energy na to. Control. So kokontrolin natin saan pupunta, ilan yung amount ng kuryente na kailangan dumaloy dito, so on and so forth. Collection is just the opposite of release. So ni-release mo dito sa part na to, ko-collect nitong part na to. Okay? And energy conversion. So energy conversion, this refers to what we call transducers. Transducers are devices that convert one form of energy into another. So in our everyday lives, marami tayong na-encounter ng mga transducers. No? Sa bahay pa lang natin, no? Pag binuksan mo yung ilaw, no? Yung bumbilya natin, it converts electrical energy into photons or light energy. Okay? Sa sinasakyan nating jeep, sa mga sasakyan natin, no? It converts chemical energy into mechanical energy. Those are forms of transducers. No? Dito sa electronics, meron tayong mga different transducers, yung mga sensors na tinatawag. So we have, for example, yung LDR or yung light-dependent resistor, wherein it converts light energy into difference into changing resistances. Yan. So posibleng lumiit yung resistance ng LDR, pwedeng lumaki yung resistance ng LDR, magbabago yung voltahe, magbabago yung kuryente. Okay? We have the photodiode, converts light energy into electrical energy. We have the LED, no? It converts electrical energy into light energy. We have the motor, it converts electrical energy into mechanical energy, yung pag-ikot niya. Rotational mechanical yung tawag doon. And all of those devices that are considered as transducers. So nagkakaroon tayo ng energy conversion dito sa electronics. So itong 5 processes na to are all important in the field of electronics. So ito, subatomic particles. So mainly electrons. But as we go on with our discussion, meron kasi tayong mga different types of semiconductor materials. The P-type, the N-type, intrinsic, extrinsic. Meron tayong, alam natin na yung electron, dumadalo yan, di ba, sa isang material. But meron pa palang isang pwede nating i-consider as a carrier, yung tinatawag na hole. So we have the electrons, yung negatively charged, and the holes are positively charged. No? Those are the subatomic particles of concern sa electronics. They act in materials with known electromagnetic properties, kagaya ng semiconductors, vacuum tube, No? Although hindi na natin pag-aaralan yung vacuum tube kasi almost obsolete na siya. Hindi na natin siya, ginagamit pa rin yung mga vacuum tubes na yan. So, pakita ko sa inyo example ng vacuum tubes. Anyway, masasearch nyo rin naman to sa inyo. So, examples of vacuum tubes para alam natin kung saan nanggaling electronics. No? Yan yung mga example ng vacuum tubes. So, hindi ko alam kung nakakita na kayong ganyan. Para siyang garapon. Vacuum meaning it's devoid of gas sa loob. Wala talagang gas sa loob yan. No? So, meron kang mga different terminals. Meron kang triode, meron kang Odion tube. Yung mga luma na yan. No? But it's still used in communications kasi mga high-powered yan. But nowadays, meron tayong tinatawag na solid-state electronics. Yung solid-state electronics is electronics that utilize semiconductor materials. So pag-aaralan natin, ano ba yung semiconductors na yan? Maybe sa future discussions natin. Kasi ngayon, I just want to focus on the basics. So ano ba yung electronics? Kailangan sa uluhin nyo to. Pag tinanong ko sa inyo ito mamaya, kailangan sa ulado nyo na agad. Okay, this is the definition of electronics I think sa NAB handbook ng electronics engineering. Okay? Okay. So anyway, kung may questions kayo, don't hesitate to ask sa ating chat box. Okay. Meron tayong tinatawag na electrical quantities. Electrical or electronic quantities. Number one, we have resistance. So probably familiar na kayo with resistance, no? Resistance actually is the property of a material to oppose the flow of charges. Ulitin ko. Resistance is the property of a material to oppose the flow of charges. Ano ba itong mga charges na to? Yung charges na to, these are considered as the free carriers. Ibig sabihin yan, basically, ito yung mga umiikot-ikot, ito yung dumadaloy sa isang material, no? Which is responsible for current. Mamaya i-define natin ba yung kuryente. No? So, ang charges natin, it may be yung electron or holes. Ino-oppose ng resistive property ng mga materials niya. Meron tayong tinatawag na resistor. Yung resistor is a device or rather a material na kinoconnect natin sa mga electronic circuits, no? That introduces resistance. So ang kanyang schematic symbol, by the way, no, when we say schematic symbol, these are symbols that represent yung mga actual na electronic device. Ito yung ginagamit natin ng mga symbol. Pero hindi ganito yung kanyang itsura in real life. The symbol for resistance is ganito. So I hope maganda yung pagkakadrawing ko. No? Siguro i-flash ko na lang sa Google kasi madulas itong aking writing pad. So the symbol for a resistor or resistance, probably alam niyo na to sa anin, sa ayan. So pangit lang yung pagkakadrawing ko. So ganyan ang symbol ng resistor natin. Meron tayong ganito yung itsura ng resistor in real life. Yan. So meron tayong 4 bands, meron tayong 5 bands, meron tayong color coding. So I hope na-discuss na rin ito sa circuits. No? So this is what we call the resistor. It has resistive properties. Ang ginagawa lang niya, it dissipates. It dissipates energy. Ibig sabihin, kumakain lang siya ng energy. Kung kumakain lang siya ng energy, anong silbi niya sa electronics? Kumakain lang pala ng energy. It dissipates energy. Resistances have different functions in electronics. One of the most basic functions ng resistance or resistor is to limit the amount of current. The amount of current. Letter I. So mamaya malalaman natin bakit letter I yung ginamit as the letter for current. Hindi ba tawag current? Ang problema sa Philippines tayo, Pilipino tawag current. Okay? So ayan. So yan yung isa sa purposes ng resistance. Number 2, it can set a voltage divider. So yan yung 2 most basic applications or functions ng mga resistors natin. Divider. Among all others. Okay? May pull down resistor, may pull up, so on and so forth. Marami pang iba. But these are the most common na pinagagamitan or function ng isang resistor or ng resistance sa electronic circuits. Ang symbol ng resistance is letter R. Ang kanyang unit ay ang tinatawag na ohms. Okay, so mamaya meron tayong kabaliktaran ng resistance. Okay, meron tayong formula for resistance. So, syempre, alam niyo na yung V is equal to IR, yung Ohm's law. Pero meron talaga tayong formula for resistance based on the property of the material. So this is what we call ρ times L divided by A. Okay? So the resistance can be computed, the resistance of a material can be computed based on its physical properties. So unahin muna natin tong L. Ano ba tong L na to? L is actually the length, yung haba. So kung mapapansin natin, it's directly proportional to the resistance. Habang umahaba ang ating resistor, mas lalo siyang nagiging resistive kasi directly proportional. Okay? Next is the cross-sectional area. Cross-sectional area, bakit yan? No? Isang cylinder. Bawa. O, pinutol mong ganyan. This is your cross-sectional area. Kapag pinutol mo sa gitna or some other part ng isang shape or ng isang object. So cross-sectional area. So habang lumalapad ang cross-sectional area ng isang material, bumababa ang kanyang resistance. Okay? Kapag lumiliit naman yung cross-sectional area ng isang material, tumataas yung resistance. Okay? Bakit? Kasi it's inversely proportional with resistance. Ano naman yung ρ? Tingnan natin dito. Ρ is what we call resistivity. Resistivity is the property of a material regardless of its length, regardless of its area. Ulitin ko. Ang resistivity is a property of a material regardless kung gaano ba siya kahaba or kaikli, kung gaano siya kalapad or kaliit, no? Resistivity will still be the same. This is similar to density. Kung naalala niyo pa yung density sa science, di ba? Density is what? Mass over volume. Anong density ng tubig? Density ng tubig is 1 gram per cc or cubic centimeter. So let's say meron kang 1 litrong tubig. Kumari na lang, litro yan ng tubig. At meron kang isang, let's say, tasa ng tubig. Anong mas marami ang volume? Siyempre, 1 litro ng tubig. Pero the question is, which one is denser? Which one is denser? The answer is, wala. Kasi pareho sila ng density. Ito yung sinasabi ko, no? Regardless of kung gaano karami yung tubig, the density will still be 1 gram per cc. Ganon din ang resistivity. Regardless of gaano kahaba, kaikli, kalapad, or kanipis yung ating cross-sectional area, no, the resistivity will still be the same. And this is dependent on the material. So first assignment ko sa inyo, I need you to memorize the resistivity values, no, of copper and mica, yung insulator, silicon, and germanium. Anyway, nandun to sa book. No, ang magiging reference book pala natin dito is Electronic Devices and Circuit Theory. Electronic Devices and Circuit Theory. CKT is circuit for short. Circuit Theory by Boylestad and Nashelski. Hindi ko alam kung ano yung latest na version. No? Anyway, almost the same din naman yung mga laman ng mga versions. May pagkakaiba lang doon sa software na ginagamit, yung simulation software. Yung, I think gumamit ng Multisim yung isa gumamit ng PSpice. Okay. Yan ang ating maging reference. So yung mga value ng resistivity na yan, nandirito sa book na to. So I need you to read that and memorize. Okay? So that's resistance. That's the first electrical quantity na gusto kong maintindihan ninyo. No? Next. Number 2. Move natin dito. Number 2 is what we call voltage or sa Tagalog, voltahe. It's represented by letter V. Ang unit niya ay volts. Ano nga ba yung voltage na yan? Let's say meron ka ditong ano bang unit ng ng electrical charge na alam natin, 'di ba? Electrons or yung coulombs na tinatawag. So ang pronunciation dito ay coulombs. Coulombs is a unit of electrical charge. So let's say meron kang 10 coulombs dito sa part A and meron kang sa part B na let's say 20 coulombs, both positive. The question is, una, which is more positive? Point A or point B? So, parang sa Cartesian coordinate system, di ba? Yan. So, this is 0, 1, 2, 3, so on and so forth, 10, 20. So, which is more positive? Yung lahat ng mga nasa kanan. And nasa kanan yung 20 compared sa 10. So, which means that this is more positive compared to point A. So point B is more positive than point A. Okay? The more coulombs that you have, provided that they are both positive, kasi pwede tayo magkaroon ng negative coulombs. Okay? The more positive it is. So mas positive yung 20 coulombs compared kay 10 coulombs. Another thing to consider is between point A and point B, there exists an insulator. Yan, insulator. Ibig sabihin ng insulator, hindi nagko-conduct ng kuryente, di ba? So, ibig sabihin, walang daloy ng charges. Mamaya malalaman natin ibig sabihin ng kuryente. So, meron silang potential difference na tinatawag. Okay? What if naglagay ako dito ng positive charge sa gitna? Saan siya pupunta? Sa point A or sa point B? So, di ba, like charges repel and like charges repel and unlike charges attract. So like charges ito, positive, ire-repel niya papunta ito from right to left. Ito negative to positive, i-attract niya from right to left. So ang movement nitong positive charge natin is from right to left. Diba? So now it has established what we call an electrostatic field. Okay, ulitin ko. If there's a difference of charges between 2 points and walang conductor sa pagitan ng dalawang points na yon, just an insulator, merong nag-i-exist na electrostatic field. But what if may conductor sa gitna? Mawawala na yung electrostatic field na yon because meron ng kuryente. May current na tayo. May explain ko kung anong current na yon. Okay? Electrostatic field is represented by E, capital E, and then merong arrow sa taas. Diba sa physics meron tayong scalars and vectors. So this is a vector quantity. It means it has a value and has a direction. So may value siya and meron siyang direction. In this case, from right to left. Yan yung electrostatic field natin. Okay. Dahil may electrostatic field, meron tayong potential difference. Ibig sabihin nun, basically, mas positive yung isang point kumpara sa isa or mas negative yung isang point kumpara sa isa. May difference in potential. Potential difference. At dahil sa potential difference na yon, meron tayong tinatawag na voltage. Potential difference is also known as voltage. Okay? Ano pa napansin natin dito? Nung nilagay natin yung positive charge sa pagitan ng point A at point B, nag-move siya from right to left. In this case. So nagkakaroon kang movement. Meron kang motion. May motion. That's why voltage is also known as electromotive force or EMF. Okay? Voltage is also known as electromotive force dahil posible siyang makapagpagalaw ng charges. Okay, electro meaning electrical in nature, motive, ibig sabihin merong motion. Puwersa, push or pull, di ba? So that is voltage, the potential difference or the electromotive force. Kaya nga yung voltahe, minsan, hindi lang V ang ginagamit natin. For voltage sources, minsan, ang ginagamit natin na letter dyan ay letter E. So minsan makita kayo ng power supply, letter E yung pangalan or yung symbol. Voltahe pa rin yun. So huwag kayong malilito doon. Voltage is potential difference or electromotive force. Okay. Number 3, the third electrical quantity that we have to understand bago tayo sumabak dito sa electrons. Wala pa tayo sa electronics, ha? Makakala nyo electronics na to. Actually, physics 2 to. Review on physics 2. 3, current. Or tawag ba current. Walang problema dahil Pilipino tayo, kung anong bigkas natin, yun yun. But I want you to practice sana yung proper na pronunciation. Current is represented by letter I kasi it came from the word, I forgot kung Russian word ba yan or whatever. Tignan nyo lang sa internet. Oh. Ibig sabihin yan is intensity or intensitat. Ibig sabihin intensity. Intensity of what? The charges na dumadaloy. Ilang charges ba yung dumadaloy? Okay? Ang unit nito is in amperes. Okay? Let's say, meron kang isang power supply or voltage source. By the way, this is the symbol of a DC power supply. So isang mahaba, isang maikli na linya. So yung mahaba, it represents the positive terminal. Yung maikli, the negative terminal. May explain ko ano ba yung AC, ano yung DC na yan. And let's say we have a switch, a simple SPST switch. May explain ko rin ano ba yung SPST na yan. Single pole, single throw. Okay. Next, meron kang let's say this is 9 volts. No? Meron kasi mga light bulbs na maliliit, usually sa mga flashlight, nung hindi pa uso yung mga LED. So let's say meron kang isang DC bulb na 9 volts din yung thing. Okay. And then you have the ground. Mamaya, explain ko ano rin ba yung ground na yan. Mamaya, nag-ground ako, nakuryente ako. Kakahiya ako kayo pag sinabi yung ground. Ay, nakuryente yung ibig sabihin ng ground. Kakahiya ko talaga kayo. Ha? So mamaya, sabihin ko kano yung ibig sabihin ng ground na yan. Okay, basically itong SPST, isang switch. Anong ginagawa ng switch? On-off. Ganun kadali. Okay? So what if i-close na natin yung switch natin? So let's say, sigurahin natin. Ay, nabura lahat. Yeah. So nag-close na yung switch natin. So this is a closed circuit. Complete na yung path. Or yung daanan ng kuryente. So what happens is, sa electronics na by the way, ang flow natin, yung tinatawag na conventional flow, is from positive to negative. Yun ang gagamitin natin. Kasi most of the textbooks and the references, they use conventional current flow. Ibig sabihin from positive to negative. But in reality, we are referring to electron flow. So ang gagawin ko muna dito is electron flow. Kasi probably yun ang ginagamit nyo sa circuits, electron flow from negative to positive. Okay. Ano ba itong mga linyang to? These are conductors. Conductors yan. Ano bang usual na conductor sa electronics? Tsaka sa electrical? Copper, di ba? Copper. So yung copper natin, meron tayong mga atoms. And then merong mga nakadikit dun sa ating valence band. Kung naalala niyo pang chemistry, yan. So mukhang itlog na merong bilog sa labas. This is the valence band, which is the outermost orbit. Ito yung ating nucleus. Anong tawag doon sa electrons na nakasakay sa outermost band? Di ba we call that valence electron? Okay. Ang valence electron can be knocked off from the parent atom. So, bago tayo pumunta dyan, discuss muna to. Kasi baka hindi niyo pa lubusang naintindihan. Bato tayo mag-slide yun. Mabalik. So, this is your atom. You have the nucleus. It's made up of the protons and the neutrons. Protons are positively charged particles, subatomic particles yan. Neutrons are neutrally charged, wherein electrons are negatively charged. The number of electrons is the same as the number of protons. So pareho lang. So ang overall charge or net charge ng isang atom is neutral. This is the overall or the net charge. Okay? So the question is, pwede ba maging positive ang isang atom or pwede ba maging negative ang isang atom? Yes, but it will now become what we call an ion. Okay? Ion, pwede kang nag-gain ng electron or pwede kang nag-lose ng electron. Paano ba tayo nakakapag-lose ng electron or paano na-knock off yung valence electron from the parent atom? So this is called the parent atom. Okay? And this is the valence electron. Valence electrons can be knocked off from the valence orbit. Okay? Number 1, exposure to external electromagnetic force. So pag na-expose ang isang atom sa isang electromagnetic force or sa isang electrostatic field, so pwede siyang kumawala. So what happens is, let's erase this one. Pwede siyang ganito. Ayan. Kumawala na siya sa kanyang parent atom. Hindi na siya nakadikit dun sa kanyang valence orbit. So this becomes what we call a free carrier. Free carrier na yung tawag dyan. Kasi pwede na siyang mag-carry ng kuryente or mag-conduct ng kuryente. Free carrier ang tawag dyan. Therefore, the atom now becomes an ion. What type of ion? Positive ion. Kasi nagkaroon na ng imba dun sa ano natin, sa positive at negative. Nabawasan yung negative, mas positive na siya. Therefore, it's a positive ion. So, posible mangyari yan if it is exposed to an electrostatic field. Number 2, if it is exposed to a magnetic field. Ano ba yung magnetic field na yan? The magnetic field is an invisible field formed by magnetic materials. So, halimbawa na lang dito yung bar magnet. Meron tayong North Pole, tsaka meron tayong South Pole. Okay? Meron tayong movement ng North to South. Ito yung ating magnetic field. Okay? Yan. So this is called magnetic flux. Yan. North to south. So if an atom is exposed to the magnetic flux, pwedeng kumawala yung ating valence electron. Okay? Number 3. If it is exposed to photons, photons basically is light energy. So this is actually the principle of photodiodes tsaka ng phototransistors. So kapag na-expose natin sa light energy yung atom na yan, the valence electron will be knocked off. Number 4, if it is exposed to heat. So pag na-expose siya sa heat, pwede siyang kumawala. So these are the reasons or magiging cause kung bakit mananock off ang valence electron sa isang parent atom. Okay, so balik tayo dito. Meron bang isang cause para ma-knock off yung mga electrons natin? Yes, meron ka ditong electrostatic field caused by the power supply, the 9-volt power supply. So listen carefully. This is negative. And this is positive. Yung negative na yon, ang gagawin niya sa electrons, ano? Negative to negative, repel. So, i-repel niya lahat nung yung electron na nandito sa part na to. So, what will happen is, kakawala yung electron. Hindi na siya nakadikit sa kanyang parent atom. Ngayon, si electron na to, because kumawala siya, it has gained enough kinetic energy. So sa physics, alam niyo naman kung ano yung kinetic energy, di ba? So yung kinetic energy niya, masyado mataas, it will collide with the next valence electron. Kapag nag-collide siya dyan, babanggain niya, it will still be knocked off. So kakawala. So magko-collide ulit siya dito, kakawala. Collide siya dito, kakawala. Until magko-collide sila, lahat ng mga electrons na yan, dadaloy dito sa ating filament ng ating bulb, ang mangyari, iilaw. Kasi it will dissipate the energy. And yung mga electrons natin na nandito, nadaloy dyan, take note, yung taas natin is positive. Anong ginagawa ng positive? It attracts the negative charges. So si negative, repel lahat ng electrons, iikot ganyan. Si positive, attract. So movement natin is from negative papunta sa positive. Yun ang tinatawag na kuryente. Okay? That's what we call electric current or current for others. No? So, current is defined as the flow of charges. In this case, nag-flow yung electron natin from the negative terminal papunta doon sa copper, papunta doon sa ating light bulb, papunta ulit sa copper, papunta doon sa positive terminal. Yun yung kuryente, pagdaloy ng charges. Okay? So the unit is in amperes. So it's represented as letter I. This is actually the derivative of charge with respect to time. So ano bang unit ng charge? Coulombs. Anong SI unit ng time? Seconds. Okay? So coulombs per second is equal to amperes. 1 coulombs per second or 1 coulomb per second is equal to 1 ampere. Okay? Wherein, ito balik tayo dito, nakalimutan ko sabihin dito. 1 volt. So this is actually derivative of work with respect to derivative of charge. Ano bang unit ng work? Joules. Anong unit ng charge? Coulombs. So 1 joule per coulomb is equal to 1 volt. Tandaan niya. So ibig sabihin nito, the energy it takes to move 1 coulomb of charge is equal to 1 volt. Ulitin natin. The energy it takes, 1 joule of charge to move 1 joule of energy to move 1 coulomb of charge is equal to 1 volt. Coulombs. Ito naman, the number of charges that flows per second is 1 coulomb per second or equal to 1 ampere. Tatandaan yan. Yan yung tatlong basic electrical quantities na kailangan yung tandaan. We have resistance, voltage, and current. Hindi ko alam kung pwedeng isend to eh. So if you want to capture na lang siguro, isa-isahin kong ganyan, capture nyo. Okay? Yan. Okay, next. So meron pa tayong ibang electrical quantities, no? We have capacitance, inductance, and we have conductance. Unahin natin conductance. May question na, wag mahiya magtanong. Okay. Number 4, we have conductance. Natin dito. Conductance. So pasensya na, no, at pangit yung talaga sulat ko kahit sa totoong buhay. Kahit na, totoo nahirapan ako sa writing pad. Kaya, mas pangit yung sulat ko, pero pangit talaga yung sulat ko sa totoong buhay. Conductance, ano yung conductance natin? Conductance is just the reciprocal of resistance. So, conductance is represented by letter G. Conductance is represented by letter G. Or pwede rin naman natin gamitin letter C. Wag na muna yung letter G kasi that's used for transconductance. Hindi niyo pa siya maintindihan sa ngayon. Okay. Conductance, letter C. But yung letter C kasi ginagamit din yan sa coulombs, no? Kaya wag kayong malilito. Kaya as much as possible, ayoko muna sana gamitin. But transconductance kasi medyo mas advanced na quantity na yan. Conductance is just the reciprocal of resistance. So kung ang resistance ay opposition to the flow of charges, yung conductance is the ease of the flow of charges. So sulat natin. Ease of flow of charges. Kung sa resistance, ino-oppose niya, eto, okay, daan ka lang, daloy ka lang. Pag mataas ang conductance, ibig sabihin, mas maraming dumadaloy na charges with whether electron or hole. No? So, pag mataas ang conductance, it means that mababa ang resistance kasi inversely proportional sila. This is one of the concepts na kailangan nyo maintindihan kasi pagdating sa transmission lines, sa communications, isa sa mga concepts yan, yung tinatawag na lamp constants. Okay? So, inversely proportional yan. So, kapag mataas ang resistance, ibig sabihin, mababa ang conductance natin. Ano ba yung may mga matataas na conductance? Yung mga conductors. No, yung mga copper, silver, gold, so on and so forth. No? So, ginagamit natin sa electronics. Anong unit kaya ng conductance? Eh, kabaliktaran siya ng resistance. Ano bang unit ng resistance? Ohms. Okay? Anong unit ng conductance? Eh, di baliktarin mo yung ohms. Ganyan yung symbol niya. Ang tawag dyan ay mhos. Totoo yan ha, di joke yan. So, binaliktad, mhos. Or, meron din tayong isa pang unit na ginagamit dyan. This is called S or Siemens. Siemens, mhos din yan. Okay? That's a unit of conductance. Okay? Probably yung capacitance siya yung inductance. Next time ko na siya i-discuss kasi gusto kong i-discuss din. Hindi ko alam kung meron kayong RC circuit. No? So, paki-comment na lang sa chat kung meron kayong na-discuss ng RC tsaka RL circuit sa circuits 1 para I'll know how to adjust dun sa ating discussions. Okay. Next. Concept of or properties of AC and DC waveforms. Ano ba yung AC? Ano ba yung DC na yan? Unahin natin AC. AC. AC is what we call alternating current. Ibig sabihin yan. Take note ha, listen carefully. Current here does not refer to electrical current. Tatandaan yan. Napakaraming nagkakamali dito. Napakarami. So makinig mabuti. It does not refer to electrical current. Eh saan siya nag-refer? Current meaning direction. Direction. Okay? So I'll just show you probably sa Scilab. Scilab is a software used for mathematical analysis. So ipapakita ko sa inyo. Kasi most of the time in mathematics saka sa different analysis, gumagamit tayo ng mga simulation software kagaya nitong Scilab. So this is an open source alternative to MATLAB in Matrix Laboratory. Kasi MATLAB mahal. No? Nasa hundreds of thousands yan. So ito libre lang to, download mo sa internet. Almost the same features with MATLAB. Okay, listen carefully kasi papagawin ko rin sa inyo to. I want to introduce Scilab to you kasi magpa-plot tayo ng mga different signals. Okay, mag-plot tayo ng isang AC waveform. Okay. An AC waveform usually exists in the form of a sine wave. Ano ba yung sine wave na yon? Yung sine wave na yon is the shape of electrical power na nanggagaling sa ating mga sockets. No, kasi yung pag-ikot ng mga generators sa mga power companies, sa mga planta, no, yung angular rotation doon, meron kang corresponding tawag dito yung angular displacement na tinatawag. So, pwede kang from 0 to 90 degrees, to 180 degrees, to 70 degrees, 360 degrees, or it can be converted to pi radians. Diba? 0, pi over 2 radians, pi radians, 2/3 pi, 3/2 pi, 2 pi. So, ano muna natin yan. No? I-drawing ko muna yung expected na output natin para mas maintindihan. Ang itsura ng sine wave, hopefully I give justice dun sa drawing. So, ganito siya. More likely, this resembles a sine wave. Ang x-axis natin, this is time. Pero pwede rin siyang angular displacement. So, ang y-axis natin, it represents the quantity. Usually, this is in volts or current. So, we have V of T. Iba sa math, anong ibig sabihin yan? May off-off na yan. V is a function of time or the voltage is a function of time. So, habang nagbabago yung time, nagbabago rin yung value ng voltage. Okay? Or, it can be a current waveform, I of T. Take note, small caps. Kasi AC. AC quantity tayo. Pag AC, usually small caps ang ginagamit natin. Kapag DC values, capitalized. AC waveform yan. So yung movement, yung pag-ikot ng mga generators sa mga power plants natin, it corresponds to a certain position dito sa ating sine wave. So 0, umikot siya, meron siya ditong 90 degrees, umikot siya, meron siyang 180 degrees, and then meron siyang 270 degrees, meron siyang 360 degrees. In radians, this is 0 radians or 0 pi radians. This is pi over 2 radians. This is pi radians. This is 3 halves pi radians. And this is 2 pi radians. So yan yung equivalent nila in terms of radians. Okay? And also, make sure kapag gumagamit tayo ng calculator at naka-radians yung angle, dapat naka-R yung ating calculator. Pag naka-decrease, naka-D. Okay. The general equation for a sine wave is ito. Susulat natin. Kailangan sa unahin nyo rin ito. Parang ang nipis ng sulat. Yan. So we have V of T is equal to V sub M times sine of 2 pi f t plus v. Okay? Sa ulo yan. This is the general equation or general form of an AC waveform or voltage. Okay, isa-isahin muna natin bago natin apply sa MATLAB, ay sa Scilab. V of T, this is what we call, dito natin sulat sa baba. V of T is what we call the instantaneous voltage. Instantaneous voltage, nagbabago-bago ng value yan. Depende sa time. So, kagaya nito, no? This is actually not in terms of time. This is in terms of angular displacement. So, dito, ang value niya is 0. Dito, let's say 10 volts. Dito, 0. Pagdating dito, let's say 9 volts. So, yung each point nung voltage waveform natin has different values, right? So, pwede ka rin magkaroon ng negative. So, pwede ka magkaroon ng -5, so on and so forth. Yung values na yon, ang tawag doon is instantaneous voltage. Ibig sabihin, this is the voltage with respect to time. Okay? V sub M is the peak voltage. Okay, balik tayo dito. This is the peak voltage. Yung pinakamataas, galing sa x-axis, at yung pinakamababa, galing sa x-axis. Yun yung ating V sub M at negative V sub M. Okay? So, pag naglagay tayo for example dito ng value ng 10, halimbawa, ang pinakamataas mo sa positive should be 10 volts. Ang pinakamababa mo sa negative ay negative 10 volts. Pwede ka bang magkaroon ng 12 volts? Hindi. Kasi ang pinakamataas mo nga dito 10. Pwede ka ba magkaroon ng negative 13 volts? Hindi. Kasi ang pinakamababa mo dapat ay negative 10, which is defined by V sub M. Sine wave is just a trigonometric function for a sine wave. 2 pi kasi radians itong unit natin. F is the frequency and T is the instantaneous time. So, i-explain ko ano ba yung frequency na yan, no? Frequency. Frequency, okay. Sulat natin dito. Tignan ko nga kung may matino akong makikita na drawing sa ano. Kasi ang hirap i-draw ng sine wave eh. Sa using ito ng sine wave. Okay, ito. Yan. Copy lang rin ito. Image. Paste. Okay. Yan yung sine wave natin ha. Listen carefully. So this is, for example, meron kang tinatawag kasi na positive half cycle and meron kang tinatawag na negative half cycle. So I call this plus HC. Plus HC. And this is negative. Kaya kakapal. Dali lang. Kapag pinaliit, kakapal yung sulat. Natin. So this is plus, ayun, tama. HC. This is negative HC. So this is the positive half cycle. This is the negative half cycle. Kapag kinumbine mo, yung plus HC tsaka yung negative HC, that is considered one full cycle. Ang isang buong cycle is composed of one positive half cycle and one negative half cycle. So it's very easy to understand. No? So what if one whole cycle, like this one, it occurs in, let's say, 1 second. Nag-i-exist siya sa loob ng 1 segundo. Ilang cycles yung nakikita nyo? Isang cycle. The question is, how many half cycles do you see sa loob ng 1 segundo? 2. Isang positive at isang negative half cycle. Pero hindi ganun ang frequency. Frequency is the number of cycles per second. So, sabi dito, within 1 second, there is 1 cycle. So, 1 cycle per second. Yan yung tinatawag na frequency. 1 cycle per second is also known as 1 hertz. Okay? So let's say, next. Let's say, etong dalawang cycle na to, nag-o-occur siya at 1 second. So ilang cycles yung nakikita nyo sa loob ng 1 segundo? 2. So that's 2 cycles per second, or that is what we call 2 hertz. Yun yung hertz. Diba? So ngayon, alam niyo na kung ano yung frequency. It's the number of cycles kada segundo. Ano naman yung tinatawag na period? Represented by capital T. Period is actually the time it would take 1 cycle to occur. Ulitin ko. The period T is the time it would take 1 whole cycle to occur. So in this case, itong pangalawang example natin, ilang seconds ang isang cycle? Ito. So itong dalawang cycle, meron tayong 1 second. Kapag ano lang, 1 cycle, ilang seconds yan? This is actually 0.5 seconds. So the period for this example is 0.5 seconds per cycle. Or we can omit the word cycle kasi understood naman na per cycle yan. So 0.5 seconds. Ulitin natin. The period is the time it would take 1 cycle to occur. Okay? So, ngayon, alam niyo na yung frequency, alam niyo na yung period na yan. Okay? Next. Oh, ano na? Time na pala. Teka. Baka nabitin tayo. So anyway, yun yung mga na-discuss natin. Marami pa ako i-discuss. Sobrang dami ko pa i-discuss. Kaya nga sabi ko sa inyo kanina, what I want you to do is focus. Makinig lang sa akin. Kung may gustong tanungin lang natin. Ayan. So those are the basics na kailangan natin. Actually, Physics 2 to. Review on Physics 2. Pero kinakailangan maintindihan to bago tayo magtuloy sa electronics. Next time ko na rin ma-show itong Scilab natin. Okay. Tapos, supposed to be prelims next week. Pero syempre, natural, wala pa tayong prelims dahil kakaumpisa lang natin. Probably magpapa-exam ako ng major exam sa midterm na. So in between, meron tayong mga quiz. Ang mga quiz natin are time constrained. Time constrained ang quiz natin. So pag hindi nyo napasa, magdadahilan na, sir, nawala yung internet. Ganyan, ganyan, ganyan. Maggawa kayo ng backup. Sometimes i-consider ko, sometimes hindi. Kasi minsan alam ko kung kailan nagsisinungaling yung mga estudyante. Nanggaling din ako dyan. Mas malupit pa yung mga ginagawa namin. Ano lang kayo ngayon mas high-tech lang. So, alam ko na yung mga dahilan ng mga estudyante. Okay, so ano muna tayo, attendance muna tayo bago tayo mag-dismiss. So dito ko ilalagay lahat ng attendance natin. Supposed to be, ano tawag dito? First part, middle part, tsaka last part yung ating attendance. But as consideration para sa lahat, ngayon muna ako mag-check. So birang-birang. Magkadugtong naman to. Yan, tamang birang-birang. Pahe, Marcelao, Samson. So tinatype ko to in order nung nakikita ko dito. Not necessarily naunang pumasok or Pancho, Tan Arabaha, Iko Bisag. Bisag. Okay. So lahat nung natin, magpo-post din ako dito ng Zoom link sa next class natin. Magpo-post din ako sa GC para sure. Kasi just in case na inspect yung CHED kasi gusto ng CHED may LMS na ginagamit yung mga school, meron kaming maipapakita sa kanila na nag-interact kami with the students. Alam mo na pakita natin GC natin, di ba? Mga personal na natin yun. Personal use na natin. Meron tayong ipapakita. Meron kami ipapakita sa kanila. Okay? So yun ang first assignment niya. Baka nakalimutan yung first assignment. Ano yung first assignment? Memorize the resistivity values based on the book of Bellstad and Nasielski. Merong mada-download niyan. Bahala na kayo. Kung gusto niyo illegal niyo i-download, bahala kayo sa buhay niyo. Basta wag niyo ako idamay. Ano yan? May mga nada-download niyan. May makokopyahan kayo ng book ni Bellstad, ng e-book. Okay? So kung wala namang concerns, o kung may question kayo, pwede naman ihabol dun sa ating group chat. Okay? So I'll see you next meeting. Bye.